prepare for a larger project in programming. Okay, so we'll have one more week before Thanksgiving, and then after Thanksgiving, as I mentioned, that will be optional attendance. I will be here to help you if you have some makeup work, and also if you want to review for some stuff to prepare for the final. And don't forget, we have one more test this upcoming week, and it's not due until the Thanksgiving week. So if you want to give yourself some time to go over that. And I believe it's like chapter 3 and 4 for the second exam. Okay, so today we're going to touch a little bit on pointers. And pointer is quite useful, especially if you are writing a larger program for different projects, as you would utilize data in different part of your memory. Pointer allows you to be able to utilize the memory address. You simply create a variable or a container that points to the location where the data would exist. The compiler would understand, and it would, instead of storing it physically on the actual variable, we can use it to create like an address location that points to where the data would exist. So an analogy of this is if you live in a house that has a home address, and when I need to find you, right, I would just need to search for that address and I will be able to locate you. So the way that we would use the pointer is it's going to point to the location of where your data exists. And so that way you don't have to create many different containers to store the same type of data or the same data. And that's the whole point, is to be more efficient with your storage using a pointer. So in this example, you would see that we have a variable x, and we would initialize that variable with an integer 10. And normally this is how we define a variable. But when you create a pointer that points to the address of x, you simply type your pointer variable. So this is going to be pointing to an integer, and you give it a name. Typically, you want to follow that with an asterisk, the little star. And that would tell the compiler that it is a pointer variable. And with that, we have to reference and dereference. So we would reference the location for X. So with that, what it will do is the compiler would understand that the pointer P is going to store the address of X, which is our original variable. So here it tells you that the ampersand of X really indicate the address of the variable X. And P, we would use that to point to, we're going to store that address because we have to have a location to store that address. And then the asterisk P is going to be the value that was from X, which is 10, right? And that would be what they call a dereferencing. So how can you apply this to real world, right? We can see it like a warehouse that store your packages to ship. The shipping label is going to have the warehouse address, and the pointer, it's going to store that address, okay? The delivery driver would then look up the label so that way they can pick up the package, right? Usually they use a scanner to do that, and that would dereference the pointer. So in example 1, you simply just have a main function. Inside it, we would declare age is 25. And we create a variable. So the standard way that you would do this is you want to type it. So integer, because it's going to relate to this variable that stores integer. So we're going to say int, and then we will follow that with the pointer. So typically it's P or PTR, and we would have the asterisk before the PTR. And as you saw in the last example, you would use an ampersand, and at this time, we would bring down the variable name that we previously declared, and that allows you to dereference that particular variable. So this is how you create the pointer for the H variable. Okay. Now in data structure for C++, you see a lot of pointer being used, and this is how we can efficiently design our program to access data quickly, is to point to the location of your data or your group of data. And we will see some of this in arrays. And so when we display, we can typically just bring down the variable, and it would also display 25. But if you want to show the actual address of the H variable, you simply use the ampersand and the variable name, because we had declared what that is, right? That's a pointer to that location. So if you want to display the actual address in memory, we're going to use the ampersand and the variable name. And if we want to display the location that holds that address, that's going to be your pointer variable name. And then if you add the asterisk in front of it, it's going to give you the value through the pointer, right? It's going to point to that value. So it's still going to be 25, but it's different ways that we access it. So I have this example written here, right? It's a short example. And if we run it, we would see, and typically you would have, let me pull this up and see if I can close that. You would see that the first time it shows the variable as the value for the variable is 25. And then when we do the ampersand and the variable name, it's actually an address location. So when you see the 0 with the hex right here, and the address in the computer system, it uses hexadecimal value. So you would see that it is a hex, so it's 0, and then it has that X symbol, right? And then everything following it is hexadecimal value. And then the pointer that holds the address is another location. So when we use that with the PTR, it shows us another address. So it's kind of like, if I want to know where you live, I would go to another, like a public, a community center that has an address, and I would look you up, right? I would look up your home address. And so that's a way that we can access the pointer, is to go to one location to find another location. And then when we use the asterisk with the PTR, it's going to show us the actual value, which is 25. So you can reference this example, and what we'll do is we would create the program for exercise 1. So we would need to write a C++ program, and we want to declare the temperature of the thermostat. It's going to be at 72 degrees. So we first create a variable, a regular variable that's going to store 72 degrees. Then we are going to declare a pointer, and we're going to use that to point to our first variable that we declared. And then we're going to display the temperature and the address, the memory address. And then we want to use the pointer to change the temperature to 85 degrees, right? It got hotter, and we want to display the updated temperature. So similar to what you've seen in the example, but we are going to use the variable to do the update. And it is more efficient this way, so if you need to change your data repeatedly, it's best to use a pointer, because it will just then do the update as we modify, instead of creating new variable each time, right? So if you need to update 5 times, you just need to point the new value to the location, and it's going to update that location with the new value. Okay, so let's look at your exercise. Okay, so let me pull this down a little bit. Maybe increase the font or the view. All right, so we have the typical include IO stream at the top. We're gonna have using namespace std for our regular standard C++ program. That's gonna give us the input and output with the header and also std for C in C out. In the main, I have a variable called temp, and you can say temperature, whatever you like. And that is initialized at 72 degrees. That was based on the exercise that's required. Then I create a pointer for my temp variable. So I would have int, and you would want to have the asterisk in front of it. You can use PTR or P, whatever you like. And then we want to declare it as a pointer. So we would have the ampersand, and we're going to bring down the variable name. And that's how you declare a pointer variable. Then we want to display the temperature as it requires in the exercise. So we would do a C out, and we want to say original temperature is, and we bring down the first variable, which is temp, to show that's the temperature. Then as you need to modify the degrees from 72 to 85, you simply use the pointer, which is asterisk P, and you would then use the update value with it. So we would say the pointer is now updated to, right? The value at the pointer location is going to then be updated to 85, right? So it's going to change, it's going to modify the original temperature, and we would use the pointer to do that. So it just point to the location and say, this location with the original value, change it to from 72 to 85. And then we want to display the new temperature. We would say the new temperature via the pointer. And at this time, after you update it, you just bring down the first variable name, which is temp, and it's going to give us the update. And we can do this repeatedly, right? So if I need to continuously to update it as the temperature would increase, you can loop it with the pointer. You can create a function and apply the loop to it. So that way, let's say that we would have an oven that changed temperature, it increased 10 degrees every minute. You can have it loop that way, right? So this is a way that we can update using a pointer. So we can modify the data and update it with a pointer. Any question? And you see the application in so many ways, right? We can do this with car speed. We can do this with, like you saw, temperature with bank accounts. You can do this with lots of other things. So it's a way that we can modify the data without having to modify the variable itself. Okay. Okay, so as you finish the program using the pointer and update the data with it, you would then test it and then just screenshot it and add it to your document. Pretty easy. So the main difference between this program and the example that you saw is that we actually take our pointer value and we would update that with the newer value, right? So you take the pointer variable and then you add the new update value to it. And then when now it's going to then point this value to the temp location that you initially have with 72. So it's going to update the the temp variable with the new value, which is 85. And so when you bring this down to display, it's going to show 85 degrees instead of the original temperature. Any question? Okay, pretty straightforward. We didn't create any separate function. You can run all of this in main. And after you test it, just add it, the screenshot of your code and your output to the document. So the takeaway that you see is that when you declare your pointer variable, make sure that you give it a name and then add the asterisk in front of that name. And for the other side of the equal sign, you want to say is, and we want to have a reference. So we want to use an ampersand, right? And then the original variable name that we had declared. Okay, so it's a way that we can point to that variable that we declared. Okay, so you can see how we can use the pointer to update for exercise 1. In the second part, part B, you are going to apply pointers into functions. And this is a way that we can deliver the data back by modifying the original value. Kind of the same concept that you saw in the part A and exercise 1. But in this case, we are going to use pointer inside a function. So if you want a function to modify the variable permanently, you can use the pointer in that function. Okay, you pass it into the function. So, and the application for this, like I said, let's say that you have deposit to your checking account, and that's going to add the deposit, and it's going to increase your checking account balance to a certain value. Or if you have a withdrawal, right, that permanently we can use the pointer to subtract the amount of money that we draw from that original balance. So you can implement it in the real world in so many ways, like for a banking application, or we can even apply it to what we saw in the previous exercise with temperature. So I wanted to use an example to kind of show you that we are going to use pointers to update our store inventory. And we are going to create a function called restock in this example. And it is not a returning function, so you use a void function here. So in this C++ program, we have a function called restock. And we would use a pointer called QTY, which is for quantity. And we have a second variable that we're going to pass into the function called amount. Okay. So if let's say that I currently have 4 bottles of juice on my shelf. And if I restock, I would add 6 more bottles of juice. Then I have to increase the total amount to make sure that I count the restock with the current amount, right? The restock quantity, we're going to add that to the amount so that way we know that we have 10 bottles of juice. So here, what you see is we would then incorporate the variable that points to our variable. So the pointer is then we're going to take it and we're going to add it to the original amount, which gives us the total, including the restock quantity. Okay. So in the main, we have 150 items in our inventory. And we're going to display the current inventory as 150. Then we are going to call the function called restock. And at this point, you want to bring the value as you pass that in the parameter. So we would do an ampersand and then the inventory variable. So it's going to take that 150 and it's going to add that with the 50, which gives us a total of 200 items. Okay? So when you pass the reference variable, it's going to update the inventory value. It's going to apply the 150 here, and it's going to increase that by 50 because restock shows that we take, right, 50, which is the quantity, and we add it to the original amount, which is 150. So when we call that function, it's going to apply the calculation, and then we are going to display the update inventory. So it then update the inventory with 200 permanently, and we would display the total, which is 200. Okay, so that's how you can implement that with the function using the pointer variable. Okay, so we're gonna use the same technique. In this example, we're gonna do exercise 2. It asks you to write a function in your C++ program to update the bank account balance from $1,000. So we start with $1,000 in our account. We are going to use the pointer to update that bank account balance and by adding the 250 deposit. So let's say I want to deposit 250 into my checking that has $1,000. So we're going to use the pointer to add the 250 deposit. We are going to display the original balance, which is $1,000, and we are going to display the updated balance, which is 1,000 plus 250, right? So same technique that you saw in example 2, we're going to apply that in exercise 2. And in this case, instead of just using the variable, we're going to do a function. So I have included IOStream at the top using namespace std for my C++ program. I create a function called deposit because we want to use the deposit to update our account balance. And we are going to pass, right? This is the definition of your function, so you need to make sure you type your parameter here. We're going to pass the pointer, which is going to be balance, and the amount, which is going to be 250. So you can use compound assignment operator here, like what you've seen in the example or the previous exercise. But I want to declare my variable here. So my balance, that's pointer, is going to be itself add with the deposit, which is amount. So it's going to update the original balance by taking it and add it to the deposit, which is stored in the amount. 250 is in amount. So this pointer variable is going to point to the original variable that store my balance of $1,000. We're working on exercise 2. So my account variable here is initialized at $1,000. I have a double account. This variable stores $1,000, right? And after that, I want to display my current balance. So my starting balance is going to be what's in the account variable. Then I'm going to call the function that I created, which is deposit. And we want to reference the value, which is in account, right? Right here. we want to reference this $1,000. So we want to say ampersand account. So it's going to plug in that $1,000 for the calculation. And we're going to deposit $250. Okay. So $250 is going to be the updated value added to the 1,000. And then we would do a return 0 to complete. So in main, we call the deposit function that allows us to update the deposit amount with your original amount. And this, because we pass, right? Because we pass the value, which is referenced in the variable account, we're able to update this permanently using the function. So when you make the deposit at ATM or on your banking app, that's what really happens in the back, is that it would use a pointer to be able to point to your balance, or sometimes they would use a pointer to point to your deposit amount, and then use that to use a function to update your total balance. And the same thing with withdrawal. So if we need to also do a withdrawal, we can create a function for withdrawal. And instead of adding, we can just subtract that withdrawal amount, right? So you get the idea. So you can go in reverse for the withdrawal. So if I deposit $250 and if I withdraw $50, right, I can take that at the deposit. So call the first function for the deposit and then create another function to do a withdrawal, and then it would subtract the withdrawal amount. And then you might have another function to do bill pay, right? And you see this on banking app. So that way you can subtract the amount that it would deduct the amount that you pay your bills through your banking app. So the takeaway for this is that when you call the function, we want to make sure that that's a reference to your variable that you previously declared, right? Which stores the original amount here. And then you would pass the value for your deposit. So 250, because it's going to plug that 250 into amount here. And it would take that and it would add it to your balance, which is 1,000. That's the calculation up here in your function. Now you can prototype the function as well, right? And then just bring the definition and put it on the bottom after main. But we didn't prototype for this one. We just simply define our function, the task that it needs to do, which is taking the balance and add the deposit. And then we call that function in the main after we declare what our account balance would be, display the original balance. We would call the function to update with the deposit and then display the updated value. So realistically, a banking app would have that, right? It permanently updates because there's no arbitrary, unless you do a simulation of potential deposits, but in the real world, you would update as you deposit or withdraw from your account. So the pointer variable, we would have the asterisk in front of that, right? And in this case, we use it for our balance, which points to the location of account variable, right? And when you put the ampersand for the account, that plugs in the value at that location, which is $1,000. So at the end, account actually holds 1250, right? Okay, so once we finish the program, test the program, and then you can take a screenshot and add it to your exercise 2 on the document. So that way you can always look at it later in the case if you wanted to review how to write pointer variables. You know that memory, the way that the system uses memory, it's dynamic, right? It's not necessarily sequential unless it is for array, okay? So if you create variable, it's not necessarily next to each other as memory addresses. Sometime it could be if that's the next available location. So the way the analogy for this is like, let's say we have brand new homes built in the community. When you buy the homes, so I have one person, person A buying the home, and the next person, person B buying the home. They don't necessarily get the home that are next to each other. That's how memory addresses work. When we dynamically store data into RAM, what happens is it just finds the next available location. So it's like selling homes to people wherever, whichever homes that are available next. So if I have one home on the first street that's available, that's what it's going to grab. It's going to give that home to the first person. And then the next person, it might be at the end of the street. That's the next one that's finished building. So the way the system efficiently use memory is just going to throw it into wherever that's available in that range of memory. Unless it's array. Array works at every single element that you use. So if I have 3 elements array, the location for those 3 elements are consecutively assigned together. So those addresses are sequential. So I would have address 1, address 2, address 3 for those 3 elements for that array. So that's why if you create an array, it wants you to declare how many elements in that array because it actually creates sequential addresses, location for your elements. So with that, we would talk about the next part, which is part C. So the way that we can use pointer is that we can use pointer to move through an array, right? So I have an array called numbers, and this container has 4 elements. So it's going to cut 4 slots, 4 sequential addresses, starting with the first element and then the next address and so on. It's kind of like the house, like an apartment building that have 4 apartments, right? And they are all sequential. So I have apartment 1, I have apartment 2, and so on. So the way that it cuts the array is it's allocating the memory address sequentially. And then I use a pointer P. How do I know it's a pointer? It has an asterisk in the front of my pointer name, variable name. And I want to use this pointer to point to my array. So when that happens, it's going to point to the address of the first element, element 0, okay? That's how it's able to locate that array because that array begins with the first element, element 0. This is why you would see that in the next line here, we simply apply that pointer and we want to increase it by 2 slots. So it's going to start at the first element, which stores 10, and it's going to move 2 to the right. So it's going to land at 30. Okay. So you can use a pointer that simply points to the first element. And then if you want to move right, you just do a plus whatever number of slots. So in this case, plus 2. So it's going to move 2 to the right. Now, what if what if I want to move to the left? C++ doesn't work this way, but in Python, we can actually move left by subtracting. So you can simply point to, when you use a pointer, it's going to go to the first element. That's the address, the beginning address of that array, okay? So if you have 50 elements, you're going to have 50 sequential addresses starting from element 0, okay? And then you can use a pointer to move back and forth. This is a quicker way how we access the data instead of using the index, because, you know, for the index, you would then have to locate like which index that is. So you can use an index, but you can use a pointer. That is more efficient. So it uses an address to point to an address, simply. Okay, so in example 3, we are going to see that we are using an array that stores the counts for our customer, like each day, how many customer do you have? So for 5 days, we put that into an array. And then we want to print out the values and find the total customer for the week. So in our 5 days, each day we would have the total, the customer count. So day 1, I have 120 customer, day 2, 130, and so on. And you simply use the variable pointer to point to the array. Like I said, it's going to start with the element 0 as the start of your address range. And we want to do a running sum to see the total customer that we have for the week. So in this case, we have 5 elements. We can loop 5 times. Okay. And we want to display each day. So day 1, so first round, it's going to display 120 customer. And then it's going to then add that as it goes. So I would take 120 and then next round, add it to 130 and so on until it reaches the end. And we would display the total customer. Okay. And so this program is simply, we use the pointer to access the array, and that allows us to start with the first element. You see how that's used here. And in each loop, we're going to increase. So after that, we're just going to go to the second element and so on. So it points to the first element to start at the beginning of the loop. And then so sequentially after that, it's going to do a +1, +2, +3, and so on until it gets to the end, which is element 4 or the 5th count for the customer. Okay, so use this technique. And what we're going to do is we're going to do the next exercise, exercise 3. Given the scenario that the car travels speed over 10 days, the first day this car drives 65 miles per hour. And as we go through, some days lower, some days are higher, right? We're going to write a C++ program that is going to implement an array for the speed. It's going to use a pointer to print out the record of speed in over 10 days. And we're going to use that same pointer to display how many days that the speed is over 70 miles per hour. Okay. So unlike the example, instead of adding everything together, we're just going to use a condition statement to check for the speed that is greater than 70 miles per hour. So we simply nest the if inside the loop. Any question regarding exercise 3? Okay. Let's look at the program. So at the top, I have the same header file. If you open your online compiler, it plugs this in for you if you use C++ 17 or 20 or higher. I don't have a separate function for this to keep it simple. I have an array called speed, and it contains 10 elements because that represents, right, the speed. Each one is the speed for each day. So we have 10 days. And you can copy and paste what's given in the scenario to your array. Make sure we use the curly brace. Then we are going to use a pointer to point to the array speed. So I have a variable called PTR. It is a pointer because we put an asterisk in the front of the name. And we point to our array, which is speed. Then I initialize another variable, and this variable is called high speed count. So I wanted to check which day has higher than 70 miles per hour. And I would initialize that at 0 at the beginning. Then what we're going to do is we are going to loop and check for each round. Okay, so that means that we have to implement a for loop. And for each loop, we're going to display the speed for each day. And as we loop, we are going to check to see if that speed is greater than 70 miles per hour. And then at the end, we're going to display how many days, right? We're going to add the days that have the high speed count, how many days that exceeded 70 miles per hour. So in your for loop, like we talked about before, we have 3 parts: how it starts, when it ends, and how it updates. So it's going to go from the first element to the last element, which is index 9, less than 10. And for each round, it's going to display the element +1 because we count day 1, 2, 3, not day 0. So that's why we use an index +1. And we want to show the speed. So here we applied the pointer. It points to, of course, the first element address, right? So you would do a pointer plus the index, which stores your miles per hour for each of the index. And we would display miles per hour. So day 1 is going to show 65, day 2, 70, etc., right? As it loops. And with that, as we loop, we want to check. So again, your pointer plus I is going to then be used in an if statement. If, right, the speed at the index is greater than 70 miles per hour, we are going to add that to the variable so we can see how many days. How many days that would have over 70 miles per hour? So at the end, we should be able to derive, right, how many days. Now, if I want specific days, then instead of, using the variable to do the increment count like this, right, I can actually do the check and then bring down the pointer and the index so in display. But you have to do that for each, for within the loop. So the application for this is we can use this to check like, maybe which day we can save gas if we don't travel over a certain mileage per hour. You can apply this into gaming in the case that if you can see like which day or which player has higher score, or which day you play game that you score higher. So there's many application in this, and you see that pointer can be applied. So in this case, we simply point to the location of the index, right? Asset loops, starting with the first index, 0. Any question? Hello? So later on, you're gonna find that they would teach you, if you pursue C++ courses, data structure, where sometimes you have to access the data from the container on both sides. Like for example, like let's think about like if we have a list, sometime we can, normally we access the list from the first item to the last item. That's what you see in array, right? That can be very sequential. So if I have like 1,000 item, if I want to go to like 999 items, it takes a long time to look through and get to, or you can point to that index. Okay. But what happens is when you have a very large group of data, what you can do is you can point to the front and the back of your list, and it's able to read that concurrently, right? So we can do it that way. We can point to the top of the list and the bottom of the list, and we would be able to access it on both sides. So as it does, it would save you 50% in how it access, the list, even if it's long. So pointer is very applicable in programming in that it simply use an address to point to another address. And so that way it can quickly access it. Okay, so once you complete this program, test it, right? Just remember that when you create a pointer variable, use an asterisk, and that basically points to the array that we created previously there. And then you can apply it in your loops and in your conditions, okay? Okay, any question? And if, just you can go back to the earlier exercise. If you want to actually see the memory address, you can print out the pointer information. So in my discrete structure class, they use recursive function. I talked a little bit about this when we talked about function. It's a function that's calling itself, and some functions are returning. So let's say that I do a Fibonacci series or something like that, where it calculates, it adds, it returns the value, and it takes that value and it uses for the next calculation. So in a very long series, like if I need to calculate many values, eventually it returns a memory address because it's not able to fetch it fast enough, right? With the limitation. So in some cases, if your compiler is not able to access the data, it just tells you the address location for that data, right? Where it stores, potentially where it stores the data. And that happens sometime with recursive function. It's not able to return the value fast enough for the calculation. So it just tells you that, oh, I would put that value here. You can find that at this location. The computer, it's only going to be doing what you instruct it to do. So in some cases, you see that. Okay. All right. Now, if you don't have any question for 3, we'll move on to 4. We're going to finish like before 4 o'clock. Okay. So in the last class, last Thursday, we talked about how we would swap numbers and we have to move things out to put things in that location, and then we have to switch it up that way, right? There's no magic space in the compiler, so you can't put it in thin air. You have to do the triangular move. Like I have to move things out of the first variable, the temp variable, to put something in there, and then after I move that one out, I would move another value in there. So that way it can get swapped. So what we can do is we can use a pointer to be able to point to values in the swap mechanism. When we need to swap 2 integers in using a function, we can apply the pointers this way. So this example is a way that we can swap seats. So let's think of one seat has one number, like on an airplane or at the stadium, and another seat has another number. So we have a function called swap values, and we would have 2 pointers. One is A and another is B. Okay. Then we declare a variable called temp. This is going to be like the middle location where we move A and B out. Okay, so one person sits at seat A and the other person sits at seat B, and we want to switch them. So first we're going to use A to and points to temp, right? And then we're going to take B and we're going to point to A. And then we're going to take on the last step, you're going to take B and we're going to point it back to temp. So if you think about it, it's a triangular move, right? You're going to first take the person A, put that person in the temporary seat. Then the seat A is now available. Then you move the person B to seat A. You point them to that direction. Go sit over at the seat A. And then now we're going to take B, right? We're going to move the B person to the temp. And so that's how we're able to completely move A to B and B to A. Okay. It's always like a triangular mechanism. Okay. So seat number 10, we're going to swap that person with seat number 25. So when you display this, so you have 2 pointer variable, you have to dereference them in the parameter. You have to use the ampersand to dereference, right, these variable there. So it's going to plug in 10 into here and then 25 into here. So when you do the ampersand with the variable name, it's simply plug in the value for that, right? And that's how you're able to swap the seat. So similar technique, we're going to do exercise 4 from example 4. So you have 2 characters in a game and you want to be able to trade power. One warrior is the level of the power is at 75 and the second character, the second warrior, the power level is 120. And we want to trade them. Okay, trade the power level. So first we want to display the original power level 75 for warrior 1 and 120 for warrior 2. Then we're going to write a function that implements the pointer to do the power swapping. The same technique that you see in the example. Then we are going to display the updated power level after the trade. Okay. So here's my program. Top, same, right? For IO. So I have a function called swap attack. And this, I'm going to use the first pointer, P1, and the second pointer, P2. I'm going to pass those so I can trade the power. Okay. Just like the exercise 4 or example 4, I'm going to have a temp variable. I'm going to use the first pointer, point that to the temp. Then now P1 becomes available, so then I'm going to use P2 and point to P1, so that way we can move it into P1. And then from there, I would do P2 into the temp. So there's a 3-step process in how we would do the swap. First, we would have a temp variable. We point the first player power to the temp. Then we would do the second player power to the first player power. And then last, second player power pointed back to the temp. So that's how we are able to move. Then in the main, we want to have, you can call it warrior 1, warrior 2, that's up to you. So we would have a variable called warrior attack, and that's initialized at 75 to start. Then let's say if you have an additional attack and you can get more points, we want to trade that. So the mage attack is going to be 120. So you can call this warrior 1, warrior 2. That's up to you. So before the trade, we want to display each player or each character level. So your warrior and your mage. Then after that, after we display each level of each warrior, then we are going to call the function swap attack, which we define at the top. And again, we are going to use reference here. So ampersand, and then you're going to go warrior attack, which plugs in 75. And then the ampersand mage attack, which plugs in 120. And so you would pass those values using the reference variable in the function call. So at this point, right, it's going to swap when you do the function call. It's going to update the value for each, and then we're going to do a cout. So after the trade, you should have the warrior at 120 for the power level, and then the mage is at 75. And I see some game, you can use this to swap like, weapons, coins, etc. And it's just a 3-step process with the pointer when you do the swap. And that's how we can switch the data between one container and another container. So after this, I'll do attendance, and then I will be around until the end of class for help. Don't forget, you have the second exam. I turned that on. It's for the earlier chapters, so you can go back and review and take the exam. As I mentioned, if you weren't here at the beginning, we have one more week before Thanksgiving, which is next week. I'll try to cover some concept for you in C++, so you're well-rounded for the next class. And then after that, I will allow optional attendance. So I'll be here if you want to come and catch up with work and get some help. I can also help you review if you need to. But final exam will be activated on during the second week of December. It will close on that Thursday on the dot. I do not allow makeup final exams, so you have the entire week. So on Tuesday and Thursday of that week, I'll be here physically. So if you want to come in to take the final using these computers, you can. Or if you want to do it at home, you can. Okay? So no big deal. But and then after that, I will post your grade the following week. Our deadline is the Tuesday of the following week. So you should see your letter grade on your app or your portal. Okay, any question? And then if I get to see you in the winter, if you're taking my classes online, that will be cool. If not, right, if some of you are in cybersecurity, likely that you will see me throughout your time taking classes in cybersecurity or programming. The counselors want me to remind you that if you need help regarding your plan for your courses, schedule an appointment. I know it's pretty booked right now, but maybe after Thanksgiving when you come back, or you can do a drop-in appointment. Okay, so the takeaway from these swap programs is that, again, right, you can implement the 3 steps process in your function to do the swap of the values. And you need to have 2 pointers to start and a variable for temporary. So it would utilize these 3 to be able to do the triangular move for the swap. And when you call that function, you want to use the reference of your previously defined variable. So it's then going to plug in the value. And the way we reference is we use the ampersand symbol. And once you do the function call, it permanently update, right? So technically you're not changing the location or anything. It just points to a different value after the function call for the end. Okay. Your data stays in one location. It just points to a different value at the end. That's it. So if you have a lot of like number updates, things like that, like for like health or weight loss application, things like that, people change over time, you can definitely implement, you know, pointers in your function this way. Okay, screenshot it, add it to your documents, After class, I will try to also update your grades in my office hours after this. And then if you have any questions outside of class, you can shoot me an email. If you need help, see me after class. Okay. Let me stop share and do attendance